In this screencast, we will solve a Coulomb's law problem using a simple calculator to handle the scientific notation. In Coulomb's law, we have a constant K, which has a value of 9 times 10 to the 9th Newton meter squared per Coulomb squared. In our problem, let's let the first charge, Q1, be 3 times 10 to the minus 6th coulombs. We'll let Q2, the second charge, be 4 times 10 to the minus 6th coulombs. And we'll let the distance between the two charges be half a meter. Coulomb's law says that the force between the two charges is the constant times the charge Q1 times the charge Q2 divided by the square of the distance between the two charges. Now we can plug in the numbers. The constant we said was 9 times 10 to the 9th Newton meter squared per Coulomb squared. Q1 we said was 3 times 10 to the minus 6th coulombs, and Q2 we said was 4 times 10 to the minus 6th coulombs. And then all that has to be divided by the square of the distance between them. That would be 0.5 meters, the quantity squared. To solve this problem with a simple calculator, we need to separate out the ordinary numbers from the powers of 10, So that would be 9 times 3 times 4 divided by 0.5 squared. And we still need to handle the powers of 10, and we have a 10 to the 9th. We have a 10 to the minus 6th, and another factor of 10 to the minus 6th. Most of the units cancel. What's left is newtons, which are appropriate units for force. With your ordinary calculator, you can multiply 9 times 3 times 4 and divide it by 0.5 squared. When you do that, you get 432. we have to multiply that by the product of these powers of 10. You remember from algebra that if you're multiplying numbers with the same base, you can add their exponents. If you add the 9 and the negative 6 and the negative 6, you get a negative 3. So this is 10 to the negative third. And the units are newtons. Now this isn't in ordinary scientific notation. It's a little odd, so we want to change it to ordinary scientific notation. So to do that, we'll write 432 in scientific notation. That would be 4.32 times 10 to the second. And we still have to multiply by our 10 to the minus third. The units are newtons. Now, we can combine the powers of 10. So we'd have 4.32 times 10 to the minus 1 newtons. And it would be okay to leave the answer in that form because that's ordinary scientific notation. But it also might be a good idea to change that to ordinary notation. Changing that to ordinary notation, we get 0.432. And the units are newtons. So there's our final answer. The force between the two charges is 0.432 newtons.